Hello students, in this video we will discuss a very important topic in quantum mechanics, eigenvalues for L square and Lz in quantum mechanics for BSc Part 3 Physics honors courses for all universities. This video is lecture 10 of quantum mechanics. इस वीडियो में हम लोग बीएससी पार्ट 3 फिजिक्स ऑनर्स कोर्सेज के लिए क्वांटम मैकेनिक्स में एक बहुत ही इंपॉर्टेंट टॉपिक को डिस्कस करेंगे, आइजन वैल्यूज फॉर एल स्क्वायर एंड एलजेड। सबसे पहले हम लोग ऑब्टेन करेंगे आइजन वैल्यू फॉर एलजेड। फर्स्ट ऑफ ऑल वी हैव टू ऑब्टेन the eigenvalue for Lz. Lz is the z component of the orbital angular momentum. Lz orbital angular momentum का z component. We can write eigenvalue equation of Lz as Lz psi equals to c psi, where C is the eigenvalue of the operator, that is the z component of the orbital angular momentum Lz, and psi is the eigen function. C is the eigenvalue of Lz and psi is the wave function. So write down for eigenvalue of Lz we have eigen value equation of Lz can be written as or can be expressed as Lz psi equals to c psi. Suppose it is equation number 1 and it is eigenvalue equation of Lz, that is z component of the orbital angular momentum, where c is the eigenvalue of Lz and psi is the eigen function. C eigenvalue of Lz and psi is the eigen function. In the spherical coordinates, Lz, that is z component of the orbital angular momentum, can be expressed as Lz equals to I h cross del upon del phi. So equation 1 in a spherical, equation 1 means eigenvalue equation of Lz in a spherical coordinates can be written as, can be expressed as I h cross del upon del phi. In the spherical coordinates we can express Lz as I h cross del upon del phi, and here Lz is operated on the wave function psi. Lz यहाँ wave function psi पर ऑपरेट किया गया है. So we can write in place of Lz as I h cross del upon del phi, and it will be operated on, it is applied on wave function psi. So we have I h cross del psi upon del phi equals to c psi in the spherical coordinates. Now solution of equation 2 can be, solution of equation 2, that is I h cross del psi upon del phi equals to c psi. I h cross del psi upon del phi equals to c psi. It is the eigenvalue equation of Lz in a spherical coordinate system. So solution of this equation, that is I h cross del psi upon del phi equals to c psi, can be expressed as psi equals to function of r theta exponential I c phi upon h cross. write down the solution of equation 2 can be written as psi equals to function of r theta f r theta e to the power exponential I c phi upon h cross, where h cross is equal to h upon 2 pi. H is the Planck constant. Suppose it is equation number 3, that is solution of the eigenvalue equation of Hz in a spherical coordinate system. I h cross del psi upon del phi equals to c psi can be expressed as, solution of this equation can be expressed as psi equals to function of r theta bracket closed exponential e to the power I c phi upon h cross, and let it is this solution. Suppose this solution is represented by equation number 3. Let it is equation number 3. Now wave function psi must be a single valued function of x, y, z, that is position coordinates. psi single valued function होगा पोजिशन कोऑर्डिनेट्स x, y, z का. Hence in this case increase in the angle phi is the angle in a spherical polar coordinate system. There are three coordinates r, theta and phi. So since psi must be a single valued function of position coordinates x, y, z, so in this case increase in the angle phi by 2 pi radian, that is 360 degree, should not change the wave function. क्योंकि वेव फंक्शन साई को एक्स वाई जेड का सिंगल वैल्यूड फंक्शन, यहाँ साई एक्स वाई जेड का सिंगल वैल्यूड फंक्शन हो सकता है. इसलिए अगर एंगल फाई में 2 पाई से इंक्रीज किया जाए तो वेव फंक्शन चेंज नहीं होगा. राइट डाउन नाउ साई मस्ट बी ए सिंगल valued function of x, y, z. In this case, increase in the angle phi by 2 pi radian should not change the wave function psi, because psi must be a single valued function of x, y and z. So that we can write f r theta e to the power I c phi upon h cross is equal to, can be written as f r theta e to the power c phi plus 2 pi upon h cross. क्योंकि वेव फंक्शन साई एक्स वाई जेड का सिंगल वैल्यूड फंक्शन है, इसलिए इस केस में अगर फाई का वैल्यू 2 पाई एंगल से 2 पाई रेडियन से एंगल फाई का वैल्यू 2 पाई रेडियन से इंक्रीज किया जाए तो वेव फंक्शन साई अनचेंज होगा, उसमें कोई चेंज नहीं होगा. Therefore we can write f r theta e to the power I c phi upon h cross equals to f r theta e to the power I c phi plus 2 pi upon h cross. It can be written as, that is f r theta e to the power I c phi upon h cross can be equal to f r theta e to the power I c phi plus 2 pi upon h cross. क्योंकि साई सिंगल वैल्यूड फंक्शन है एक्स वाई जेड का, पोजिशन कोऑर्डिनेट्स का और कार्टेशियन कोऑर्डिनेट्स का एक्स वाई जेड. देयरफॉर एंगल फाई में 2 पाई रेडियन से इंक्रीज नहीं किया जाएगा तो वेव फंक्शन अनचेंज रहेगा, साई दैट विल आल्सो साई. सो वी कैन राइट साई इक्वल टू एफ आर थीटा ई टू द पावर आई सी फाई बाई एच क्रॉस इक्वल्स टू is equal to f r theta e to the power I c phi plus 2 pi upon h cross. Psi will be the same. Therefore, since write down the wave function psi must be a single valued function of x, y, z, coordinates x, y, z. Hence, change in angle phi by 2 pi radian, 2 pi or 2 pi radian will not change the wave function psi, will not change the wave function psi. दोनों सिचुएशन में वेव फंक्शन उतना ही होगा जितना कि एंगल फाई के केस में है, उतना ही फाई प्लस एंगल फाई में 2 पाई से इंक्रीज कर दिया जाए तो ऊपर भी वेव फंक्शन अनचेंज रहेगा, क्योंकि वेव फंक्शन साई एक्स वाई जेड का सिंगल वैल्यूड फंक्शन है. चेंज द फंक्शन, चेंज द वेव फंक्शन will sorry the wave function psi must be a single valued function of x, y, z. Hence, change in angle phi by 2 pi will not change the wave function psi. That is, the wave function psi will remain unchanged. If the angle phi is changed by or phi is increased by 2 pi radian. Therefore, we can write psi equals to equation 3 now expressed as psi. Since the wave function remains unchanged, since the wave function will remain unchanged, since the wave function will remain unchanged, so psi equals to f r theta. F r theta is the function of r and theta. That function e to the power I c phi upon h cross, and it will also and psi will also equal to f r theta e to the power I c phi upon h cross in equation 3, and the wave function will be unchanged if phi is increased by phi plus 2 pi. So psi will also equal to f r theta. We can write f function of r theta e to the power I c phi plus 2 pi, phi plus 2 pi inside the bracket if the angle phi is changed by increased by 2 pi. So we can write e to the power I c phi plus 2 pi upon h cross, and both will equal to the wave function psi because the wave function psi will not change. So psi equals to f r theta e to the power I c phi upon h cross equals to f r theta e to the power I c under bracket phi plus 2 pi h cross. So we have now we can write since both are equal, therefore f r theta and f r theta will cancel out. So we can write we have e to the power I c phi upon h cross equals to e to the power I c phi plus 2 pi upon h cross. We can write e to the power I c under bracket phi plus 2 pi upon h cross as I c phi upon h cross into e to the power I c phi upon h cross into e to the power I c 2 pi upon h cross. So further we can write f r theta e to the power, f r theta will cancel out in both sides, so we can write e to the power I c phi upon h cross in LHS equals to e to the power I c phi upon h cross multiplied by e to the power I c 2 pi upon h cross. ब्रैकेट को अगर हटा दिया जाए तो वी कैन राइट इट आफ्टर रिमूविंग द ब्रैकेट I e psi 2 pi upon h cross e to the power c phi upon h cross and e to the power c I c phi h cross will cancel out in both sides. So we have e to the power I c 2 pi e to the power, that is exponential I c 2 pi upon h cross equals to 1, and hence therefore we have 2 pi c upon h cross equals to 2m pi. Therefore we can write, since I e to the power exponential I c 2 pi by h cross equal to 1, therefore we can write c 2 pi upon h cross equals to 2m pi 2 pi c upon h cross e to the power I c 2 pi by h cross is equal to 1. Therefore, we can write c into 2 pi or 2 pi c upon h cross equals to 2m pi where m is a small m is an integer. So 2 and 2 in the numerators of LHS and RHS will cancel out, and therefore pi and pi will also cancel out in both sides, that is in LHS and RHS. Pi and 2 will cancel out in both sides, that is in LHS and RHS in the numerators. So we have c upon, we will left with c upon h cross is equal to m. Therefore, we will obtain the value of the eigenvalue which is c. C is the eigenvalue of the operator Lz और z component of orbital angular momentum. तो इसी हमने शुरू में ही सपोज किया है कि c क्या है, वह Lz का ऑर्बिटल एंगुलर मोमेंटम का z कंपोनेंट का आइजन वैल्यू है, तो आइजन वैल्यू c है, उसका वैल्यू अभी हम लोग ऑब्टेन करने जा रहे हैं. इन एलएचएस वी हैव c by h cross and in RHS only m, small m is an integer. Therefore c equals to m h cross. C is equal to m h cross, and suppose it is equation number 4, and c is the eigen value of Lz, which is a small m into h cross is h upon 2 pi. Thus we have obtained the eigen value of Lz, that is z component of the orbital angular momentum, and eigen value of Lz we have already taken as c. So c equals to, we have obtained c equals to a small m into h cross. This is the eigen value of Mz. The eigenfunctions of Lz can be also obtained if we put the value of c in equation number 3. So the eigenfunctions of Lz are, putting c equals to mh cross, that is the eigen value of Lz equals to c equals to a small m into h cross. Putting this value, that is c equal to mh cross in equation number 3, we have psi eigenfunctions of Lz are psi equals to f r theta. Psi equals to eigenfunctions of Lz are psi equals to f r theta e to the power c mh cross, h cross will cancel out, so we will e to the power I m phi. So eigenfunctions of Lz are psi equals to f r theta, function of under bracket r is the position coordinate, theta is the angle in the spectral polar coordinate. F r theta in polar coordinate we can write there are two coordinates f r theta, and in the spectral polar coordinate there are three coordinates r theta and phi. In this case function of r theta and phi is in the third coordinate in the spectral polar the third coordinate phi of the spectral polar coordinate system is in the term e to the power I m phi. So psi equals to, the eigenfunctions of Lz are psi equals to f r theta e to the power I m phi. After putting c equals to m, a small m h cross in RHS of, that is in the exponential term of equation number 3, c equals to mh, putting c equal to mh cross, h cross will cancel out in the numerator and denominator, so we will left with psi equals to f r theta e to the power I m phi only. So psi equals to f r theta e to the power I m phi. Suppose this is equation number 5, and this represents the eigenfunctions of Lz. Eigenvalue of Lz, eigenvalues of Mz are represented by C equals to M H cross, where M is an integer, M equal to 1, 2, and so on. Now eigenvalue for L square. अब हम लोग L स्क्वायर का आइजन वैल्यू ऑब्टेन करेंगे इस वीडियो में आगे. सिंस द वैल्यू ऑफ ऑर्बिटल एंगुलर मोमेंटम L is finite, therefore L square will also be finite. That is, L square has a definite fixed value which does not change. If we operate psi with either Lx, Ly and Lz, the value of L square remains unchanged. Therefore, L square commutes with either of the orbital angular momentum components Lx, Ly and Lz. क्योंकि एंगुलर मोमेंटम कैपिटल L फाइनाइट होता है, इसलिए L स्क्वायर भी फाइनाइट होगा. L स्क्वायर का फाइनाइट फिक्स्ड वैल्यू होता है जो कि वेव फंक्शन साई के साथ Lx, Ly एंड Lz को ऑपरेट कराया जाए तो L स्क्वायर का वैल्यू अनचेंज रहता है. इसलिए L स्क्वायर ऑर्बिटल एंगुलर मोमेंटम के 3 कंपोनेंट्स Lx, Ly एंड Lz के साथ कॉम्प्यूट करता है, जिसे हम लोगों ने प्रीवियस वीडियो में, इस चैप्टर के प्रीवियस वीडियो में डिस्कस किया था, वीडियो नंबर 9. नाउ इफ psi m is an eigen function of Lz with eigen value equal to image cross, which we have already obtained in this video. The eigenvalue of Lz equals to a small m h cross. M is an integer which has 12 plus 1 values, and a small m is also called magnetic quantum number. So write down, if psi m is an eigen function of Lz, that is z component of the orbital angular momentum, with eigenvalue equal to image cross, then the function Lx plus minus Ily, where L plus raising operator, L plus equals to Lx plus Ily, and L minus, which is the lowering operator, which decreases the value of m, L minus. So L minus can be written as Lx minus Ily operated on psi, that is the function Lx plus minus Ily psi m is also an eigen function of Lz. क्योंकि अगर सपोज किया जाए कि psi m आइगन फंक्शन है Lz का, जिसका आइगन वैल्यू इमेज क्रॉस है, जिसे हम लोगों ने इसी वीडियो में अभी थोड़ी देर पहले ऑब्टेन किया था, Lz का वैल्यू इमेज क्रॉस. तो psi m आइगन फंक्शन है Lz का विथ आइगन वैल्यू इमेज क्रॉस के साथ. देन द फंक्शन Lx plus minus Ily operated on the eigen function psi m is also an eigen function of Lz, that is द फंक्शन Lx प्लस माइनस I Ly ब्रैकेट क्लोज्ड ऑपरेटेड ऑन साई m भी Lz का आइगन फंक्शन होगा, जहाँ रेजिंग ऑपरेटर n प्लस इक्वल्स टू Lx प्लस I Ly एंड लोअरिंग ऑपरेटर n माइनस can be written as Lx minus ILy. Raising operator increases the value of m, while lowering operator L minus, that is Lx minus ILy, decreases or lowers the values of m, the small m. That is, the small m is an integer which has 12 plus 1 values, and it is also called magnetic quantum number. Now repeated applications of the operator, ranging operator L plus equals to Lx plus ILy will produce eigen functions of a fixed L square, because value of L square is fixed, belonging to indefinite large eigen values of Lz, for which in repeated applications of the operator Lx plus ILy, that is raising operator L plus is equal to L plus is written as Lx plus ILy, will produce eigen functions of a fixed L square, since value of L square is fixed, we know, belonging to indefinite large eigen values of Lz, unless there is some value of m, a small m, for which Lx plus ILy psi m vanishes, because a small m has also limited values, that is 12 plus 1 values from minus L to plus L. Therefore, there is some value of m for which the raising operator Lx plus ILy psi m and the function raising operator is Lx plus ILy operated on the wave function psi m. So it is Lx plus ILy psi m vanishes. ये वैल्यू वैनिश करेगा, Lx plus ILy ब्रैकेट क्लोज psi m का वैल्यू वैनिश करेगा फॉर सम वैल्यू ऑफ m, स्मॉल m के सम वैल्यू के लिए Lx plus ILy ऑपरेटेड ऑन psi m, दैट इज L plus ऑपरेटेड ऑन psi m will vanish for some value of a small m. तो Lx plus ऑपरेटर रेजिंग ऑपरेटर L plus, that is Lx plus ILy का रिपीटेड एप्लीकेशन वेव फंक्शन psi m पर फॉर ए फिक्स्ड आइगन वैल्यू L स्क्वायर, क्योंकि आइगन वैल्यू L स्क्वायर का फिक्स वैल्यू होता है, वो अनचेंज होता है, और corresponding to indefinite large eigen values of Lz के large indefinite values के लिए, जब तक कि unless there is some value, जब तक कि m के कुछ पर्टिकुलर के कुछ वैल्यूज के लिए Lx plus ILy psi m माइनस करेगा. And similarly, repeated applications of the lowering operator L minus, that is Lx minus ILy on the wave function psi m will lead to indefinitely large negative values, because lowering operator L minus decreases the value of m. So the lowering operator L minus, that is Lx minus ILy operated on, that is repeated application of lowering operator L minus, that is Lx minus ILy on the wave function psi m will lead to indefinitely large negative values of m, unless Lx minus ILy psi m vanishes for some values of small m. उसी ढंग से लोअरिंग ऑपरेटर Lx minus ILy का वेव फंक्शन psi m पर रिपीटेड एप्लीकेशन से एक फिक्स वैल्यू L स्क्वायर का एक फिक्स वैल्यू के लिए, क्योंकि L स्क्वायर तो फिक्स होता है, L स्क्वायर है ए फिक्स वैल्यू विच डज नॉट चेंज, तो L स्क्वायर के फिक्स वैल्यू के लिए Lz का लार्ज माने इंडेफिनिटली लार्ज नेगेटिव वैल्यूज m का ऑब्टेन होगा, जब तक कि m के कुछ खास वैल्यूज के लिए Lx माइनस ILy ब्रैकेट क्लोज्ड साई एम वाइनिस नहीं हो जाता। इस प्रकार रेजिंग ऑपरेटर एल प्लस दैट इज एल एक्स प्लस आई एल वाई एंड लोअरिंग ऑपरेटर एल एक्स माइनस आई एल वाई का वेव फंक्शन साई एम पर रिलेटेड एप्लीकेशन से लार्ज वैल्यूज ऑफ आइगन फंक्शन लार्ज वैल्यूज ऑफ एजेड का लार्ज वैल्यूज आइगन वैल्यूज ऑब्टेन हो सकता है जब तक कि फॉर ए फिक्स्ड एल स्क्वायर फॉर ए फिक्स्ड वैल्यू ऑफ एल स्क्वायर का वैल्यू फिक्स होगा तो एजेड का लार्ज इंडिफिनिट नंबर ऑफ इंडिफिनिट लार्ज नंबर्स ऑफ इंडिफिनिट लार्ज आइगन वैल्यूज एजेड का ऑब्टेन होगा जब रेजिंग ऑपरेटर एल प्लस को ऑपरेट किया जाएगा साई एम पर जब तक कि कुछ एम के कुछ खास वैल्यूज के लिए एल एक्स प्लस आई एल वाई साई एम दैट इज एल प्लस साई एम वैनिश नहीं कर जाता दैट इज जीरो नहीं हो जाता। उसी ढंग से लोअरिंग ऑपरेटर एल माइनस दैट इज एल एक्स माइनस आई एल वाई का वेव फंक्शन साई एम पर रिपीटेड अप्लाई करने से उसको रिपीटेडली अप्लाई करने से एल माइनस को साई एम पर रिपीटेडली अप्लाई करने से दैट इज रिपीटेड एप्लीकेशन से भी एजेड का लार्ज वैल्यूज लार्ज इंडिफिनिट वैल्यूज इंडिफिनिटली लार्ज नेगेटिव वैल्यूज ऑब्टेन होगा फॉर ए फिक्स्ड एल स्क्वायर जब तक कि एम के कुछ वैल्यूज के लिए एल एक्स माइनस आई एल वाई साई एम वाइनिश नहीं हो जाता। Now suppose m1, a small m1 and m2 be the two limiting values such that the generating procedure terminated. Then we can write apply ranging operator on psi m1 give the value maximum positive value m1 of hz plus hz upon h cross and m2 that is operation of the loading operator L minus that is Lx minus ILy on psi m2 on the wave function psi m2 will give the maximum negative value of m2. So we can write we have let m1 and m2 be the two limiting values such that the generating procedure terminated. We can write Lx, we can write Lx plus ILy that is ranging operator in place of Ls in place of L plus we have written Lx plus ILy. Ranging operator increases the value of m while lowering operator decreases the value of a small m. So we have Lx plus ILy psi m1 equals to 0 and suppose it is equation number 1 in Roman and similarly the operation of L minus the lowering operator on the wave function psi m2 gives the maximum negative value a small m2. So we have and Lx minus I Ly psi m2 and this will terminate the generating procedure will be terminated. Then we can write Lx plus ILy psi m1 under bracket closed psi m1 is equal to 0. Suppose it is equation 1 in Roman and similarly Lx minus ILy that is lowering operator operated on wave function psi m2 is also equals to 0. So it is equation number 2 and this will happen when the generating procedure will be terminated for two values of m that is m1 and m2. m1 is the maximum positive value of hz upon h cross while m2 is the maximum negative value of hz upon h cross because the eigenvalue of hz is equal to a small m into h cross, therefore a small m is equal to Lz upon h cross. Where m1 is the maximum, m1 is the maximum positive value of Lz by h cross, and it is consistent with a given value of L square, and because the value of L square has a different finite value, fixed value, which remains unchanged. L square का value change नहीं होता है, and m2, a small m2 is the maximum negative value of Lz upon h cross. Now apply L square. We have to obtain the eigen value of L square. So apply L square on psi m1, and similarly we will apply L square on psi m2. So L square, now L square into psi m1. L square can be written as Lx square plus Ly square plus Lz square. So it is Lx square plus Ly square plus Lz square. L square की जगह पर Lx square plus Ly square plus Lz square लिखा जा सकता है. Since we know that L square is equal to Lx square plus Ly square plus Lz square. Bracket closed, operated on psi m1 for the maximum positive value of Lz upon h cross. Now in RHS we can write Lx square plus Ly square as B bracket. Now Lx square, in place of Lx square plus Ly square we can write under B bracket. Now under small bracket, starting with big bracket. Now a small bracket, Lx minus Ily into Lx plus Ily minus I under bracket Lx Ly minus Ly Lx. In place of Lx square plus Ly square we can write under bracket Lx minus Ily into under bracket, under small bracket, Lx plus Ily minus I Lxy, I minus small I under bracket, under small bracket, Lx Ly minus Ly Lx. So in place of Lx square plus Ly square we have written under bracket Lx minus Ily bracket closed into under bracket Lx plus I Ly bracket closed minus I under bracket small bracket Lx Ly minus Ly Lx, and last term is inside the bracket is Hz square. Lx square plus Ly square की जगह हमने यूज किया Lx minus Ily bracket closed into Lx plus Ily minus I under bracket Lx Ly minus Ly Lx. तो इससे हमें ऑब्टेन हो सकता है फिर से Lx स्क्वायर प्लस Ly स्क्वायर एंड प्लस लास्ट टर्म इज इनसाइड द ब्रैकेट इज Lz स्क्वायर. सो इट इज Lz स्क्वायर. नाउ बिग ब्रैकेट इज क्लोज्ड, बिग ब्रैकेट psi m1. नाउ वी नो दैट द कम्यूटेशन रिलेशन ऑफ Lx comma Ly equals to Lx Ly minus Ly Lx equals to I h cross Lz. So in place of Lx Ly minus Ly Lx, sorry, in place of Lx Ly minus Ly Lx we can write I h cross Lz. Outside the bracket is I, so I into I square minus 1 and minus minus plus. I के पहले माइनस है, so I into I square minus 1 और minus plus and plus h cross Lz. We can write now plus h cross Lz, and the value of Lz is m1 h cross. The value of Lz is, eigen value of Lz is m1 h cross, and in place of Lz square, last term is Lz square inside the big bracket. So in place of Lz we can write m h cross the whole square, that is m1 square, that is m1 h cross the whole square, that is m1 square h cross square, and bracket closed and psi 1. Now we can write L square in LHS it is L square psi m1 equals to, in RHS we can write Lx ILy into Lx ILy into psi m1. अगर psi m1 से मल्टीप्लाई कर दिया जाए ब्रैकेट को हटा करके, if the bracket is placed and if we multiply Lx minus Ly into Lx plus IL by psi m1, and since using the condition Lx plus IL by psi m1 is equal to 0 and also Lx minus IL by Lx plus IL by psi m1 is equal to 0 using the condition 1. So first term becomes 0, 0 and in place of Lx plus IL by psi m1 we have used the condition 1 given by equation condition given by equation 1 and it is 0, and second term is now minus I under bracket Lx Ly minus Ly Lz is I h cross Lz and I into I minus I into I square which is minus 1 minus plus, so it is 0 plus first term is 0 for Lx plus ILy psi m1 plus h cross Lz, and Lz is the value of Lz is m1 h cross, so it is h cross Lz. We can write for Lz m1 h cross psi m1 multiplied by psi m1 plus last term is Lz square psi m1, Lz is m1 h cross whole square psi m1 or L square LHS is now next we have L square psi m1 is equal to m1 h cross square or h cross square m1 psi m1 plus m1 square h square last term is m1 Lz square psi m1, the value of Lz, eigenvalue of Lz is m1 h cross, so it is m1 h cross whole square which is m1 square h cross square, so it is m1 square h cross square psi m1 it is L square psi m1 equals to h square m1 psi m1 plus m1 square h square psi m1. So taking common m1 h cross square in RHS in both terms of RHS के both terms में m1 h cross square present है, तो m1 h cross square को common ले लिया जाए RHS के both terms में, तो हम we can write L square, therefore L square psi m1 equals to h square m1 is taken common, h square m1 is taken common. So in the first term psi m1 can also be taken as common. So in the first term it is 1 and in the second term it is m1 because m1 h cross square is common. In the second term it is m1 square h square. So second term में क्या बचेगा m1, first term में क्या बचेगा 1 क्योंकि h स्क्वायर m1 टोटल टर्म कॉमन ले लिया गया है, psi m1 भी कॉमन हो गया है, तो 1 plus m1 or we can write m1 plus 1. So inside the bracket it is m1 plus 1 and psi m1 is also common. So it is L square. Finally we have obtained L square psi m1 equals to h square m1 under bracket m1 plus 1 bracket full psi m1, and suppose it is equation number 3. Similarly, by using the lowering operator, that is L minus ILy, similarly we can obtain for psi m2 for the wave function psi m2 or the maximum value negative value of m2, we can write L square psi m2. So write similarly L square psi m2 equals to h square m2. Now m2 is the maximum negative value of Lz upon h cross. So L square psi m2 equals to h square m2 under bracket m2 minus 1. लॉरिंग ऑपरेटर m के वैल्यू को रिड्यूस कर देता है, तो m2 minus 1 psi m2 and suppose it is equation number 4. So we have obtained L square psi m1 equals to h square m1 under bracket m1 plus 1 by using raising operator L plus, that is when L square is operated on psi m1. So we have L square psi m1 equals to h cross square m1 under bracket m1 plus 1 bracket close psi m1. It is equation number 3. And similarly we can obtain L square psi m2 equals to h cross square m2 under bracket m2 minus 1 bracket close psi m2. If both equations, that is equations 3 and 4, are to be true simultaneously, then we must have m1 under bracket m1 plus 1 equals to m2 under bracket m2 minus 1. So write down if equations 3 and 4 are to be simultaneously दोनों इक्वेशंस एक साथ अगर ट्रू होगा, दैट इज इफ इक्वेशंस 3 and 4 आर टू बी साइमल्टेनियसली if equations 3 and 4 are to be true simultaneously, अगर दोनों इक्वेशंस 3 and 4 एक साथ अगर ट्रू होगा तो उस इक्वेशन में then we must have दोनों इक्वेशंस में we have m1 under bracket m1 plus 1 bracket closed equals to m2 under bracket m2 minus 1. Or we have in LHS we have m1 square plus m1 equals to m2 square. In RHS it is m2 into m2, that is m2 square minus m2 into 1, that is minus m2. So we have m1 square plus m1 square plus m1 equal to m2 square minus m2, or we can write m2 square minus m1 square equals to m1 plus m2. साइड चेंज किया जाए m1 स्क्वायर का, so we can write m2 स्क्वायर माइनस m1 स्क्वायर, एंड फिर m2 का साइड चेंज किया जाए, माइनस m2 है RHS में, LHS में प्लस m2 हो जाएगा. तो एंड m1 स्क्वायर LHS में पॉजिटिव है, RHS में लाने पर निगेटिव हो जाएगा. तो इट इज m2 स्क्वायर माइनस m1 स्क्वायर को RHS में ले जाया गया एंड m2 को LHS में. तो m2 स्क्वायर वी हैव m2 स्क्वायर माइनस m1 स्क्वायर इक्वल्स टू m2 plus m1, and now we can write m2 square minus m1 square equals to m2 minus m1 into m2 plus m1 using the formula a square minus b square is equal to a minus b into a plus b. So in LHS we have m2 square minus m1 square can be written as m2 minus m1 under bracket into m2 plus m1 under bracket equals to m2 plus m1 in RHS, or we have m2 plus m1, taking m2 plus m1 common, and m2 minus we can take m2 plus m1 in RHS. So we have m2 minus m2 plus m1 into m2 minus m1 minus under bracket m2 plus m1 equals to 0. We can write taking m2 plus m1 in LHS. So we have m2 minus m1 into m2 plus m1 minus m2 plus m1 is equal to 0. Or taking m2 plus m1 as common in both terms. So we have the first term it is m2 minus m1 m2 minus m1, and in second term it is m2 plus m1 is taken as common, so it is 1 minus 1 is equal to 0. So either it is equation number, say it is equation number 5. So either m2 plus m1 is equal to 0, either m2 plus m1 is equal to 0, that is m1 equals to, that is m2 is equal to minus m1, or m2 plus, either m2 plus m1 is equal to 0 means m2 is equal to minus m1. Say it is equation number now 6, and or either m2 plus m1 बराबर 0. Therefore we have obtained m2 is equal to minus m1, and it is equation number 6. And m2 minus m1, inside the bracket it is m2 minus m1 under bracket minus 1 is equal to 0. So we have m2, or we have m2 minus m1 minus 1 under m2 minus m1 under bracket minus 1 is equal to 0. Taking 1 in RHS, therefore we will m2 minus m1 equals to 1. So we have the result is m2 is equal to minus m1, and m2 minus m1 minus 1. So we can write m2 is equal to we can write m2 minus m1 minus 1. So we have m2 minus m1 is equal to 1. Therefore m2 equals to m1 plus 1. So taking m1, a small m1 in RHS, we have m2 is equal to m1 plus 1. m1 को माइनस m1 को RHS में ले जाने पर m2 का वैल्यू होगा m2 is equal to m1 plus 1. But this cannot be accepted. This value cannot be accepted. This is equation number 7. m2 is equal to m1 plus 1 cannot be accepted because m1 is the maximum positive value of Lz plus H cross. क्योंकि m1 स्मॉल m1 Lz अपॉन H क्रॉस का मैक्सिमम पॉजिटिव वैल्यू है, उसका वैल्यू m1 से ज़्यादा अधिक नहीं हो सकता है. लेकिन यहाँ इक्वेशन 7 में हमने ऑब्टेन किया है m2 इज इक्वल टू m1 प्लस 1, तो विच कैन नॉट बी एक्सेप्टेड, क्योंकि m2 का वैल्यू m2 जो है मैक्सिमम निगेटिव वैल्यू है Lz अपॉन H क्रॉस का. तो m2 is equal to, और m1 क्या है, and m1 is the maximum positive value of Lz plus 1. So this value m2 is equal to m1 plus 1 cannot be accepted. So we have only m2 is equal to minus m1. This value will be accepted. But m2 equals to m1 plus 1, it is inadmissible. It cannot be accepted. So we have m2 is equal to minus, therefore we have m2 equals to minus m1. So we have only value of m2 we can only value of m2 which can be accepted is m2 is equal to minus m1. So we have m2 equals to minus m1. Suppose it is equation number 9 in Roman. Now writing L, a small l for m1 in equation 3. So now writing L for a small l for m1 in equation 3. We have equation 3, L square psi m1 is equal to m1 h square under bracket m1 plus 1 psi m1. So we can write equation 3 as L square psi m1 in LHS, and in RHS it is m1 h cross square. So in place of m1 we have to write L. m1 की जगह इक्वेशन 3 में स्मॉल l यूज किया जाए, स्मॉल l, और m1 को स्मॉल l से रिप्लेस किया जाए. So we have first term is m1 square, that is L square, so that is RHS is m1 h cross square, m1 h cross square under bracket m1 plus 1 psi m1. So it is h cross square m1. So in place of m1 we have to write a small l, we have to replace a small l. So it is L square, LHS of equation 3 is L square psi m1 equals to h cross square. In RHS it is h cross square m1, and in place of m1 we have to write a small l, we have to replace a small l. Inside the bracket it is m1 plus 1, so it is l plus 1, bracket closed. So we have RHS is h cross square, a small l under bracket l plus 1. In place of m1 we have replaced a small l. So it is h cross square, h cross square small l under bracket l plus 1 into psi m1. So we have obtained L square psi m1 equals to h cross square l into l plus 1 psi m1. Psi m1 and psi m1 in both sides will cancel out. So we have now we have obtained the eigenvalue of L square as, so L square is L square as L into L plus the value of L square is the eigenvalue of L square is h square L into L plus 1. H square L into L plus 1. And suppose it is equation number 10. Hence eigenvalue of L square is h cross square, a small l under bracket L plus 1. Thus we have obtained the eigenvalues of Lz and L square both in this video. Now this video is completed. Thanks all of you for watching my YouTube channel.